Hi, my name is Jay Torres. I'm a sales engineer in the HVAC industry based in California. And today I wanted to talk to you about VRF product and application. What is VRF? VRF, or Variable Refrigerant Flow, is a scalable zoning system. It provides higher level of comfort, control, and efficiency, and we do this by using individual fan coils for each zone and using inverter compressors in the outdoor unit. And VRF is an adaptable technology, meaning it can be used on multiple types of applications, including K through 12, university, hospitals and healthcare, hotels, office and mixed-use buildings, multifamily. Any type of building can be a good candidate for VRF. Now, there are two different types of VRF. You have heat pump and you have heat recovery. In a heat pump system, fan coils are capable of providing either cooling or heating based on the outdoor unit mode. So if one zone calls for cooling, then the entire system can only be in cooling. And likewise, if a zone calls for heating, then the entire system is in heating mode only. With heat recovery, fan coils are capable of providing simultaneous heating and cooling. So if you have one zone that calls for heating and then you have another zone calling for cooling, both of those zones can be satisfied at the same time by the same outdoor unit. And there are two different kinds or two different types of heat recovery. You have 2-pipe and you have 3-pipe. In a 2-pipe heat recovery system, you have two mixed phase lines. Currently, there's two manufacturers that I know that use this technology. You have Trane Mitsubishi and you have Carrier. And you also have 3-pipe heat recovery, which uses 3 refrigerant lines. You have a liquid line, a suction line, and a hot gas line. Manufacturers that use this technology are Daikin, LG, Toshiba Carrier, and Samsung. Let's look at a heat pump system. Let's look at the different components of a heat pump system. You have your outdoor unit, which controls the compressor speed, and it maintains the operational mode. So this is what tells the entire system to be either in heating or cooling. You have your indoor units, which transfers the hot air or the cold air to the space. And this is what allows for optimal zoning because you can use individual indoor units at each zone. And you also have your controls, your thermostat or remote controller, which gives the end user control of their indoor unit. Here's a basic layout piping schematic of a heat pump system. This one is a Carrier system. So you have your 2 refrigerant lines coming out of the outdoor unit, Y branching into each indoor unit, and each indoor unit is connected to its own remote controller. The Toshiba Carrier, very similar. You've got your 2 refrigerant pipes coming from the outdoor unit, Y branching into each indoor unit, and each indoor unit has its own remote controller. Good applications for a heat pump. Basically any large open space that have single common zones are good candidates for a heat pump system. So for example, you have gyms, hotel lobbies, churches, large common office spaces where they will all be in the same heating profile or cooling profile. Those would be good candidates for a heat pump system. Now let's look at a heat recovery system. The primary components of a heat recovery system are similar to a heat pump, but on a heat recovery system, you have a flow selector box or a branch selector or a heat recovery box. This is what controls the state of the refrigerant to the indoor unit, and this is what allows for simultaneous heating and cooling in a heat recovery system. And again, you have the other components as well, the outdoor unit, the indoor unit, and the controls. Here's a 2-pipe heat recovery system. So this would be similar to a Trane Mitsubishi or a Carrier 2-pipe heat recovery system. All the components are the same, but on this Carrier 2-pipe heat recovery system, you have your multi-port distribution controller, and this is what controls the state of refrigerant to the indoor unit. What are some good applications for a heat recovery system? Basically, buildings with many thermal zones, buildings with diversity. If you don't know what diversity is, I plan to do a separate video on diversity. If you want to see that video, please leave me a comment in the comment section below. But any building with multiple thermal zones, so for example, classrooms, offices, hotels, assisted living facilities, these are all good applications of a heat recovery system. A question that we get all the time is, where do we want to use 2-pipe versus 3-pipe heat recovery? You typically want to use 2-pipe heat recovery in a 1 to 2-story building. Wider buildings where you have a central location to mount your MDC. These MDC boxes tend to be larger, so placing them centrally in a building makes the most sense. And then you can home run to each indoor unit from that MDC box. You also TI and shell and core buildings can be good candidates for a 2-pipe heat recovery system. So say you have a building that has multiple tenants and they're not all filled out once the building is turned over. You can cap all those pipes coming from the MDC and add future equipment as future tenants move in. You can also do this in a 3-pipe heat recovery system. You can also use 3-pipe heat recovery for taller, skinnier buildings. Mid-rise to high-rise office buildings, hotels would be good candidates for 3-pipe heat recovery. And that's what I wanted to go over today, just a basic overview of VRF, how it works, and the different flavors of heat recovery. If you like this video, give me a thumbs up. If you want to see more videos, leave me a comment below, and I'll see you guys in the next one. Thanks.